Hello. Please first let me make a selfie because I have been here first time, so would be cool to have it in album. Okay. So let's start. A moment. Who am I? I'm tech art lead and lead for graphic programmers also, and for FX guys and lighting guys. So generally it's between 9 to 14 people in the team. I've been working on a bunch of titles. You can see this on screen. And I have around 12 years in experience. I have tried to make presentation to help not only graphic programmers optimize games, but also VFX artists, lighting artists, and just 3D, 2D artists. So there will be a bunch of information for you, not from only one category. I hope you will like it. First will be about just the sources of problems in Frostpunk 2. Because it's quite a large game and with a lot of problems that we have had to tackle. Later we will talk about visible in view, our tech internal, about Nanite something will be, about multithreading, procgen, then fake lights, just some tricks and tips, VAT animations, custom name event is more about profiling. And the last thing is about quality balancer, the thing that a bit rescued us, especially for China market. So, the problems. Frostpunk 2 has 4 views that are blending seamlessly and are transiting without very visible switch. Our art director wanted to make it feel that the player is just scrolling up and down to zoom in and zoom out. We have here 3 to 4 cities, around 100 points of interest on the map, and it's the largest zoom out. Okay. Here is also use of 3D environment. It's mapped by post-process and so on, so it's looking like a typical map, but under the hood, it's still rendering the whole landscape. And of course, it requires smooth transition to next view, which you will notice that it's very different. And of course, we have the weather effects similar to what we had in Frostpunk 1, just here is a bit more stylized because it's carto view. What happened? Misclick, sorry. Next thing is realistic or Frostland view. Here we have already seen, we can see just typical 3D art with high environment details, full weather support, and still, again, smooth transition between this view and city view. You can also see on the screen that city is just visible here, everything that you have built. So if you have there, for example, 1,000 buildings, you can see here it too. And the city view. As I said, over 1,000 buildings for the mid to full city, with animations, with custom behaviors, with meltings, with smokes, generally a lot of things like traffics, which can contain people, automatons, trains, or fireflies. Fireflies are those time-lapse effects on the roads that are flickering and showing just traffic in high speed. And of course, we have thousands of smokes and lights, which is pretty heavy. At least it was before optimizations. And another perspective is close zoom. also named as zoom stories. Here we have high details, we have animations, skinned, meshed. We have a lot of realistic lights. It's not like fake lights here, it's like shadow casting. We have better quality fog and so on. So how to merge it? Because those are, let's say, 4 games in one game, okay? You cannot make it like, hey, I have a single setup and it's just working, okay? You have to make it working dynamically. So first thing is our system visible in view. You can think about it as an alternative worlds where we have, for example, one building with high quality placed, and on the same place is placed, for example, low quality building. It's not LOD, but it can be very different look, because also the problem here we had to tackle is not only the poly count or render draw calls and so on, but also how those things are looking from the very different distances. So this thing is extension that allows us to define on which view what kind of objects are visible. And it's not only for example, meshes, but also for particles, for fog, for partially, or even for lighting. So when we are switching the view, we can, for example, turn on very different particles, or, for example, we can make a collective smoke instead of single smokes per building, for example. And it gives quite high, well, performance boost later, because this is merged also with cooling per city area. As I said, we have 4 cities, and each city can have, for example, 1,000 buildings, and these buildings can have multiple meshes, multiple people, and so on. So we had to make our custom cooling. So with integration with this visible in view, which is, as I said, or maybe not, the extension for Unreal. It's not like modification for engine in most cases. It's mostly like injection for the flow for Unreal. If you look at, for example, plugins for DLSS or FSR, you can also notice that they are injecting some parts into Unreal workflow. So this current cooling per city area gave us around 3 to 10 milliseconds, which is quite big. And it's mostly for render thread and, well, CPU costs, because the most expensive here thing was not rendering itself, but it was cooling, which could take a lot of times, because we have thousands of objects. And it's not only, you know, buildings that we have 1,000, okay, or 4,000 or 10,000. It's about, for example, tiles for roads, for pipes, which are in 100,000s, okay? So it's pretty big. In some moment, we had even problems with amount of objects in Unreal, because we reached the limit of objects that we had. And it was mostly because of rendering. Next thing is that we are using a lot of mask captures, okay? It's for melting, for tension behaviors, for some protests in-game, for fogs, generally a lot of things. And we have noticed that Unreal has a lot of boilerplate code that triggers distance fields computations, lumen computations, occlusion cooling computations, or even virtual textures refreshes. And for example, we could even reach 4 or 5 milliseconds loss because of some updates that are not needed for render targets, okay? Especially if those render targets are colliding with some lights areas or some meshes that are on scene, because Unreal batches those SDFs and lumen things, and they are just also triggered from scene captures. Even if you disable the lighting, if you even disable all the features and you leave only just linear rendering there, it's still problematic. So it's worth for you to look at those features and try to disable it. On the screen, you could also see that we have a tool to show off the different views. And as you can notice, there is also idea tree and HOD. Just this visible in view was quite a cool thing to differentiate views and make just rendering cheaper. Without that's what's also important. We don't set is visible to false or true. It's more in render moment to define what is visible and what's not. And it's based mostly on behavior similar to what we have in scene captures when you set up actors to be rendered or components to be rendered. Just that's the only modification in engine that we had to make for main camera. Okay, so how to solve 1,000 buildings? Building has a single building can have 5 meshes plus add-ons like chimneys or some stuff on roofs, which are mostly visible. And our Urbos procgen tech has to handle it, which is not easy. For example, housing has also 14 tile variants. So as you can imagine, it's not easy to batch when you have, for example, 14 of them in single district. And those districts we can have, for example, 30. Yeah. And well, here it comes hierarchical and static meshes for rescue, but not in typical style because it was quite limited to some features that I will tell you about, but still it was worth to use it. And as I said, Urbos is our internal tech for procgen things. It's generating roads, it's generating buildings, pipes, and just make a lot of, it generates most of the city. So, probably the first question will be why we haven't used Nanite. We have tried it. We started developing a game when Unreal was on 4.2, and we ended on 5.4. And we have tested Nanite when it was 5.0 or 2. I don't really remember, sorry. But when we have enabled it and configured it properly, performance was dropping a lot. We could even lose 15 FPS on 4060 RTX, for example. So it's much. The reason was that we had too many variants of materials. That was first thing, and it's not like that we had spreaded those materials. When you are zooming out, like on this background, you can see pixel density switch for materials is too high, and Nanite cannot make proper mesh shaders there, calculations and so on. Next thing is that most of our buildings have VAT animations, so a lot of vertex offsets, a lot of animations, movement, and so on. It also kills Nanite. So it was quite heavy to make it feasible for our pipeline also, because it was quite late moment. It was, we have tested it around 1.5 years ago, or maybe 2. So we were close to closing the Frostpunk 2. So even with agreeing that we will change the pipeline, we couldn't be able to reach the final goal probably. So we decided to leave it. And so we are going back to HIMS. First thing is that we have custom tool to decide to select the object that should be batched, because typical Unreal batching is breaking the flow of it under many cases, and it's generally hard to make it batching into HIMS in ways that we want. And please remember that everything is from procgen and it's spawned dynamically, okay? I know that you can bake on static scenes and so on, but there's nearly nothing spawned statically. So that's also the case. So we have made a tool that you are selecting the static meshes or other mesh-like objects, and you are selecting, hey, we will batch it into a certain group. And, well, it just do this. System scans it, reacts on changes, and, well, it's working pretty well. As you can see on the screen, that's how Batcher worked for example, housing. And this case is most important for low-spec devices, of course. Next thing is that we had to make custom parameterization for those buildings because we want some fancy stuff like, hey, let's make some melting on snow for especially one of them. Or let's make some dirt, or let's make animations, because if we are using VAT animations, I will tell about them later. We need to update the data, okay? And we cannot just make, hey, let's batch it. And that's the next thing for Unreal system of batching. You have to make updates, and you can make it either or by making new material instance, which is just heavy, or you can make custom data, okay? And those custom-made data are working pretty well, but it's quite problematic to manage when you have a lot of objects on the scene. And next thing, why we have used hierarchical instanced measures instead of instanced measures? Those first are allowing to change the LODs, to make proper cooling and so on. So it's just giving us more possibilities to optimize in expense of more expensive cooling and more expensive, in general, render thread flow, okay? Because it has to iterate over the LODs and so on to find out what's best for rendering at the end. So we had to make also some custom modifications. So we can use different HMS group sizes, make some instancing per mesh, per material, and that's the main thing here. But there is this part of code, not commented one, but the below one, which shows that Unreal expects from us to set up the value where we are changing the group of instancing to another one. And it's pretty good for foliage, for example, because you are setting, for example, that you are grouping those objects, those objects per, for example, 100 vertices or 1,000 vertices to another group of batch, because we are quite limited by rendering and so on. And, well, the bigger batch, the more expensive draw call, which is not cooled. It's not like we are cooling mesh by mesh, but group by group. But as you can see, old code is limited to just one comment, okay? And when we want, for example, proper splitting groups for leaves, for trees, for rocks, it won't work for example, buildings or for bigger rocks. For example, Frostland or cartography view. As I said, we have different views, and they need different approaches also. So the easiest way here is just to add custom control. And for example, it's like, hey, I want to make that every 10th building or 100 building, we are getting the new group. And it's working much, much better in this way. Also, it's worth to test for foliage and for trees. It can be even handled by artists to configure it later, so they can look at how LODs are working when they are changing, and if it's worth to make smaller groups or bigger groups. Okay, and next thing. I don't know if you have been on presentation from Paweł Harzyński yesterday. He made a presentation about VFX and how to optimize them. And, well, we have a lot of them. I mean, VFXs. Here are around 2,700, but we can have even more. And it's only one city, okay? We have also on Frostland, we have winds, we have weathers, and everything just cost, okay? And if you would like to put this just manually or even procedurally, but just spawn system by system, you will kill Unreal instantly. I don't remember what was the count where it makes significant difference, but it was around 500 Niagaras or even less, where it was just dropping FPS down. So we have Niagara emission points. It's our system that is similar to a new feature named Niagara channel data, but it's a bit simpler to configure for artists because in those new Unreal feature you need to define it by yourself or whole system. But here you are just making emitter and you use one function to sample the position, the custom data, and it's work automatically, like, you know, drag and drop, and it's working. For example, to change the fountain from typical Niagara system to our system use, it's like 5 minutes or even less. And you can spawn that much Niagara effects, and it's pretty cheap. On the bottom, you can see comparison for GPU, and well, here is around 7 milliseconds. It's old screen, by the way. Now gain would be higher because we have much more people after update, which are also particles, by the way. Here is not visible draw cost. I haven't noticed it previously when I was making a copy of the screen, but draw cost was also way lower after using emission points. And how it does work? Generally, we are putting component emission point to places where we want to spawn particles. We set up a group type and so on, some kind of restrictions, and we have one emission point route per group, per some area, because it doesn't have to be for the whole city, but for example for district or just for some large group of particles. And this emission route takes emission points from this area and transfers the data to Niagara system. It's probably quite simple code, to be honest, but you need to make some multithreading to make it work fast. But in general, it gives a lot of it makes just a lot of easier life for VFX guys to set up the whole scene. Because otherwise you have to make some strange optimizations which are not frequently working that well, and you are limited to hundreds of particles instead of thousands. And yeah, one more important thing here is that it requires some custom data paths also, because, for example, we have some fade-outs, or when we are getting tension, protests in game, we want to make, for example, smokes into red, and those things also need some customization data, but it's still easy to implement here. Next thing is that we had a lot of struggles with CPU times, of course. First thing is that, one moment. Okay, I've missed one point here. We are using ECS system, semi-ECS. It's entity component system, which makes that we are not using ticks from actors, from components. We are putting components as a functionalities, and systems are iterating over those components for certain groups, for example, movement or emission points. And they are updating the data for them. The plus is that, for example, we can compute objects in batches. Later I will tell you about multithreading, but the thing is that you can, for example, make it asynchronous, and in this way, if something doesn't fit into the time frame, you can put it later, for example. That's the next point about. Another thing is that you can sort executions from most important to less important. For example, if you have transports, automatons, or even animations, okay? Because VAT animations also require some CPU approach, updates. You can sort, for example, from distance or by visibility, because if you are on Frostland, it's clear that city view updates are less important than Frostland view. Also, we can try to ignore what player doesn't see, and don't. Here's the important thing, that we shouldn't always follow that what Unreal gives us by default, okay? Because some expectations of cooling may be missed, and of course in Profiler it's visible that something is rendered or updated, and we can be shocked sometimes what's updating. For example, we have one system that makes a cooling for landscape. Lumen works like this, that if you have high angle or low angle, sorry, of sun, it also blocks cooling for landscape because it casts shadows. But those shadows are frequently not visible, so you can just make another cooling under certain range and make tiles of landscapes, for example, much lower count. Next thing is, of course, multithreading. In Urbos, in our procgen, we are using it by a lot. I remember the times that our Urbos was generating single district for 10 seconds, so it was unplayable without another thread computations. Now it's way faster, but still it's, for example, 1 to 2 seconds to compute everything, especially if we have very high districts or there are expectations to make something fancy, like when you sign up cornerstones and we have some add-ons to spawn with. By the way, spawning is also a good thing to make budgeting, so you don't spawn everything from, for example, district or single building on a single frame, okay? It's much better to smooth it by different frames, and this is also what the entity component system helps here. And of course, well, we have some fancy algorithms like quadtree, star, and so on, and it helps, but well, it's frequently very time-consuming to implement, so it's always the question if it's worth it. And that's about the next point. I frequently see that some people who are starting with optimizations are trying first to focus on some very, very low-cost things, and well, they waste time, for example, a month to optimize something, and they get, for example, only half a millisecond. Of course, that's also the gain. But the thing is that what I always do, I first check what is over 1 millisecond cost in rendering and in CPU, in hitches also. And first I look at them, and maybe later I go deeper to check what's under the hood, okay? Because, for example, you have multiple draw calls, and single draw call is quite cheap, but if you look at, for example, opaque cost, it may be very expensive. Oh my God. So multithreading. 1 moment. We have, as I said, we have used the semi-entity component system, and it was quite cool because, for example, we have 1,000 objects of automatons moving on roads, and they all need to update, okay? And they are not particles. Half by half, okay, because it's still controlled by CPU, but they are rendered later by emission point system. But in general, it's like making pathfinding, following paths, going to one place from another is handled by CPU. And if we would use just a tick, like on tutorials from YouTube, probably we would kill game after 100 or maybe 1,000 updates. It will just get dropped to 30 FPS or 40, just with just raw automatons. So if we make asynchronous computations here, or we make some special thread for computations for those automatons, it's much cheaper. Of course, it depends on how much threads cores you have in CPU, but well, most of people don't have now one core only in PC. Okay, so next thing is that procgen helps a lot. Generally, making procgen is quite time-consuming. We are spending a lot of time to maintain it, to develop it, especially if you want to make some art director requirement, follow some requirements from art director, because well, for example, a typical L system is like you are moving some snake and turn left, turn right, snap to roads, to grid, and that's all, plus some rules. But if you want some stylized connections, some special behaviors on slopes, or going under the terrain, it's just getting harder and harder. But generally, procgen is quite cool for optimizations because, for example, I can say that for high-spec devices, we have full city, but for low-spec devices, we have, for example, only 5 buildings per district. And with just one click, we can get 20 frames. Okay, about automatons, I already said that multithreading helps for pathfinding, also for people, for traffics, but also it helps for effects. Some of effects require some special treatment, like, for example, melting or behavior for weather, for updates for fog, that are, for example, reacting on some special behavior. For example, we have melting render from top down, but also we have, which is updated also on compute shader and so on, but also we have, for example, melting from moving automatons which is made in another way, and it requires also special threading or updates. Fun thing is that I have changed my approach to multithreading when I met Thread Ninja from Unity Asset Store. I don't know if you know this plugin, but it's quite cool to work with. It behaves like coroutines from Unity, but in a way that in single function you can select that first I want to make it in background computations, later go to foreground computations, and I'll put everything on single function, which is very easy to make a code, and it's very clear also to manage. We have wanted to make something similar for Unreal, but we have used C++17, which doesn't have coroutines from C++20. So we made our own approach. It's mostly based on queue and on dependencies between certain calls. We are making just a list of tasks which are called sequentially. And well, the one of most important thing is that we are nearly not using any logs. I mean, of course, there are some sync points that we had to make, especially for managing the queue, okay? But inside the calls, we are mostly making either copy of data or we are jumping to the main thread to make some synchronizations. So there is no problem with that. We have, for example, 10,000 of logs in the same time, plus deadlocks and so on. And it's, well, pretty cheap. Here's an example of how that kind of call looks like. So we are first adding to main thread. We are setting, for example, static. Oh, by the way, some things in Unreal are working only in main thread, and it will just cause crash when you will call it in backgrounds. So this is also important thing that this cheap jumping is very easy to use in that kind of case that I show you here. So main thread, background thread, heavy computations, and then go back to main thread and set, for example, visibility. And the interesting thing is that when we make a pool of that kind of requests, a list of that kind of requests, we can, for example, even operate on different sources from different sides. But if we make a pool per source, for example, Urbos for generation, okay? We are not. We can work without worries that something else, some other thread, will get access to our source in the same time and in another thread. So that's quite a cool thing that by making this kind of queue, we are safe from mutexes and semaphores. Okay, so going back to procedurally generated city. It's quite scalable. We can change cost from 10 to 1 milliseconds into clicks. When you look at the settings in Frostpunk, it's like going back to main menu, changing setup, and then you can, for example, use some cheats. I don't know if it's mod released cheats, but you can just generate the same city, and it's working instantly without any problems. And what's important for here for China market, for example, is that we had problems with China market that many users had, for example, RTX 3060 or even lower, but just something not very poor, but some of them had broken cores, for example. Those devices were cheaper and so on, but players expected that it will work perfectly, okay? Or, for example, we had cases in analytics that we had seen that someone had 8-core processor, at least that person should have these 8 cores, but then it appeared that it was only 4 cores, for example, which is quite painful, especially if you expect that when you are giving specification for game, yes, for requirements, and the player will download this game with this specification, it will work as you expect, and well, it's not. Plus, for that kind of procgen, for optimization, is that systemic generic approach makes also optimizations easier because you have some expectations for rendering, for how buildings will be built, how roads will be built, and it's just maybe not the same, but it's predictable, okay? As you can see on this screen for L system rows, for grids, each that kind of dot is single tile, will be single tile. So there are hundreds of tiles rendered, and if we wouldn't have something predictable, our frame time would probably skyrocket instantly. And going back to some tricks, should we use lights or not? Because we are still on deferred renderer, so generally each presentation shows that we can use hundreds of thousands lights, and well, it's just working, okay? Well, it's not if you are using if you have game that you have limited frame times and so on, and you are not just making a scene from lights, okay? So what's enough? What's here enough? Here are just quads, okay? As I said, we have different visible views and different mechanics for switching how we are looking at something. And well, from far distance, we see only quads, not lights, at least for roads, which as I said, we can have thousands of them. Next thing are story glimpses. This is just mechanics that disables and enables actors or components when we are out of view. For example, we can disable avalanche or dust and make it just cheaper. And next thing is quite interesting because if you put multiple objects which are rendering fog, I'm not saying you know, the fog component typical, but for example, fog cube with fog material, and you put them in many places instead of single place and a single mesh, fog expense will be much bigger because it multiplies the draw calls in general. There is some kind of batching and so on, but it's not always working. So, what's the difference between point light and without point light? On close zoom, it's visible, but when we are looking at from farther view and it's animating, lumen is moving and so on, it's not that much visible. So it's just worth to look at the game, check the scale that you are using, and think if we really need this point light, or especially point light with shadows. That's the worst thing. And another trick. For example, signboards on our buildings are made from single mesh. We have mesh with multiple quads placed inside it, painted with vertex shader, and when we are moving those meshes, and it's also in Sunset, by the way, it just randomizes the shown text or just some texture basically on the position, which is quite easy to set up, and Of course, you can limit it to, for example, 2 or 3 groups to make it for hospitals, for housing, for production, and so on. But in general, it's very, very, very easy to optimize and also quite easy to set up. And animations. We are using mostly vertex animation textures for rendering. We have a special system which updates on multi-thread. Well, it supports mainly, it supports multi-threading, instancing with this previous system for batching, which makes animations 1,000 or even more thousands quite cheap. We are not using skeletal animations because in that count it would be very, very expensive, okay? We are using Houdini for baking VAT animations with lots, which is important because when you are generating lots outside of engine, you will break the VAT animation. But also I know that some guys are using Blender and it's working pretty well too. Okay, this VAT animation system also is supporting some VFX, sounds triggering. It's a bit painful to configure because we are not using timeline here. We are just triggering on some time that is configured there. Maybe later we will make some timeline. So generally, sound guy hates me by configuring it, because of configuring it. But what's the cost? First cost is, of course, memory. The more animations you have, the bigger cost is, and it's quite hard to get rid of it from memory. Okay, if you are looking at the whole scene and all buildings are animating and so on, you cannot unload it. You cannot compress it because VAT animations don't like compression. Okay, so it comes with some limitations unless you don't care about memory. And from our side is 1,000 by 1,000 texture size. But here is an interesting thing that Houdini has quite a nice system for optimizing this texture. And even if you have 4,000 vertices, it can still produce 1K texture. And this is the single piston from production, where we can have, for example, 8 in single building. So you can easily count how much we can have later of it. And of course, we are using profiling tools, many of them. This is only for PC. We have also for consoles. And generally, well, first thing is Unreal Insight for CPU, render thread, tasks. For Slate, for example, it's also worth, just don't use it in editor in this case, because it gives wrong data. Peaks for rendering, memory port is cool thing to getting info where's missing memory or where we are using too much memory. Well, previously we have used session frontend, but in later versions it's not used. Also statistics is quite cool thing, and of course stat units, stat FPS, and so on and so on. On the bottom you have command that allows you to make high detailed profile GPU information, which I have learned on some other presentation, but it's not commonly known when you are looking at internet. So yeah, worth to note here. And custom named event. It's a thing for Unreal Insights. And for example, you can put it into HIMS computations for some engine, but also for your things. Plus of this approach is that you can name it however you want, and just keep it in some debug value, and later use it to make this stats counter and look at it in any site. But you need to remember that you need custom named event enabled when you are running Profiler. Next thing is quality balancer. That's also a thing that rescued us in China market. First is saying benchmark. It's a benchmark that is run to check what's the performance of the device. So we are not checking that, hey, you have RTX, the latest one, and for example, 100 gigabyte of RAM, and you are getting ultra high quality and so on. No, we are checking how the device is performing, and that's totally all. There's an exception with Mac because this benchmark is not giving good results, but that's the only one thing. Another thing is that we are using quality mapping. So when we have rated the PC, we are going to some ranges of those rates, and we are changing qualities. And well, we have also balancing in runtime, and this balancing is making a lot of job, because, for example, when someone has set quality to high without knowing that how expensive can be RTS game later, when we have built whole the city, balancer just makes quality drop, and when frame rate is going down, and for example generates less buildings. And final tip, well, plan optimizations. Optimizations are frequently treated as analytics, for example, where hey, we are about to release the game, and oh, we have only 5 frame rate, and well, what we are going to do because it's unplayable. So better is to plan it. I'm not telling that from every step you should optimize, because it can be too much time consuming, okay? It's better to plan, for example, architecture for optimizations, or plan some kind of milestones where you are checking what's your frame rate, what's your render cost, and so on. So that's generally that. Okay, thank you. Do you have any questions?
Okay, many questions. So now, you said that you use else systems for procedural generating. That green points that we saw on the presentation, that's like the most possible nodes for certain roads or for certain buildings. Is that true? Okay. So now it's a question: why it's problem with technicality, or it's more game design that we have sometimes hexes, or sometimes we have 5 sites. You know what I mean, like in game. That's the second part of the question. And another part of the question is when you created the procedurally generated pipeline, do you take into consideration that PCG in Unreal?
Okay, PCG is quite new thing, and well, problem with generation of meshes, for example, is that you cannot make instancing there. Okay, it would work, for example, for Nanite, Sorry for answering the second question, but
I put 3 questions at once, sorry.
okay. When you have that kind of big city, you cannot allow to generate meshes because you won't be able to batch it in instancing. You can batch it just as a mesh, and of course it can be also a quite cheap thing, but taking scale of the game, you would have a lot of meshes which are well, killing memory in this way. So that's the first thing. And that's why we are not, for example, generating the meshes of the roads. Because we could, for example, use splines, which are pretty heavy because how they are work under the hood, and just use it, okay? But, well, for amount of roads, it's not possible to make it properly, especially that as a player, you can, for example, build each district in times frame, for example, 1-2 seconds, and on every district spawn, you are generating the whole roads because we have some, art direction approach for this, and they need to frequently generate all the city again. So it's first, it's very expensive for CPU, of course, for generating, but also for spawning. It's much easier to make instancing where you are just putting instances on the positions and adding the configuration rather than generating whole mesh with, for example, 10,000 poly or even more. There's also important thing that when you are generating procedural mesh, you are quite limited to poly count of those meshes which you are bending and so on. Because if you will make a mesh with 1 million poly, bending, going by spline, it would be very painful. But when you are using instancing with some fancy shader that is bending something, it's much cheaper. About those first question, well, the one main problem or challenge was to fit some art direction. And for example, we want those circular shapes, but sometimes we want to organic merges, or we want to have tubes or jumping from slopes. And it's not easy to go through those old paths and make it perfect, especially when you have very uneven terrain. We had made some tries to, for example, flatten the whole terrain around the districts, which made road generation much easier in this case, but it didn't look good. And still you are, for example, even if you make, for example, perfect snapping for road, for terrain, you need to remember that we have trains. Trains are not going very high. You have people, you have automatons, and it still requires some changes. And for example, some of them are moving on CPU, so you cannot make, for example, just by shader snapping to SDF, to height map, or RVT, for example, because we are using here RVT to get the base shape of the landscape. So yeah.